Alright, let's talk about molar volume. Now some questions that will require this molar volume are things going to read, how many liters would moles of a gas something or another at STP? How many moles of a gas liters STP? Liters, gas, STP. I hope you're seeing the trend. You have to realize that on your cheater chart, which, well, reference page, whatever, that you get on your EOC, there is this lovely conversion right here. It says molar volume at STP is 22.4, and that goes with the top letter, liters for every 1 mole. This can be used as a conversion factor. So you have to realize you can write 22.4 L over 1 mole, or 1 mole over 22.4 L. And use that as a conversion factor, just like an added bonus on your mole heart. So, if you ask you how many liters would 3.5 moles of O2 occupy at STP, well, if you have 3.5 moles O2, we know for every 1 mole, it's going to have 22.4 liters at STP. Then you just have to multiply 3.5 times 22.4, and you'll get 78.4 liters. That's lovely. Now, if it wasn't at STP, then you would have to use your PV equals nRT. But molar volume is super awesome when it's at STP. So in this question, it says how many moles of nitrogen gas would occupy 7.5 times 10 to the second liters at STP? Well, we still start with the number they gave us. Please remember that if it's in scientific notation, you're going to have to put that in parentheses in your calculator just to be safe. And this is liters. So now, since the liter is what we need to get rid of, we follow regular dimensional analysis rules. We put 1 mole on top, 22.4 liters on bottom, so this time we'll be dividing. So when we type our calculator, we'll have to do 7.5 times 10 to the second, close parentheses, divided by 22.4, enter, to get our answer. If we're keeping sig figs, this is a conversion, it doesn't count, 2 sig figs, so 33, look to the right, 4 is less than 5, so our answer would be 33 moles N2. Now this question's sneaky. It says how many liters would 350 grams of O2 gas occupy STP? Oh no, there's no moles. But you know what? We can still use our mole heart and use the molar mass of oxygen to change grams to moles, and then use our molar volume. So if we have 350 grams O2, first, we need to find the molar mass of O2. So I know for every 1 mole of O2, it's going to occupy 2 times the molar mass of oxygen because it's O subscript 2. So in my calculator, I'll do 15.999 times 2, which comes out to be 31.998. And so we'll do 350 divided by 31.998. That comes out to 10.94. Now I'm going to keep some extra sig figs because I'm in the middle of my problem. I'm not done. So that's moles O2. But I don't want moles, I want liters. But thankfully we are at STP, so then all I have to do is start a new problem. 10.94 moles for every 1 mole of any gas at STP. It has a volume of 22.4 liters. So I'll be multiplying 10.94 times 22.4, and that will occupy 245.0 yada yada liters. Now, since we started with 3 sig figs, that's what that decimal after the 0 tells us, then we just need 245 liters O2.